Derivative in lambda. The derivative is an operator that is applied to a function. It is used in infinitesimal calculus, also with all its applications, for example in economics and in physics. It can be written with different notations. If I have to do the derivative of the function y equals 3x to the second, I can write it in various ways. For example, a capital D, and in square brackets, the argument of the derivative, that is the function to be derived. Sometimes there are also superscripts and subscripts, because they have extremes. Many times, in an even quicker way, you simply put a superscript. So the derivative of y equals 3x to the second is used to write that y prime, meaning the first derivative, is 6x. Or f prime of x, that is this superscript. A superscript indicates precisely the first derivative. In other cases, both in differential equations, but also in physics, the derivative is expressed with a superscript. Let's see how to write all these. When, on the other hand, it is necessary to specify the variable with respect to which the derivative is made, as in the case of partial derivatives, or in the case of nth derivatives, meaning of higher order than prime, it is sometimes necessary to write it in the form dy over dx, which is also the form of the differential. The only case in which we then have an open, close, possibly a separator, in the case of a derivative index. It should be noted that this notation is generally not used much in the calculation of derivatives. It is not repeated. It is found in texts, in the theoretical part, or in the formal description of the subject. In general, the previous procedures are used, which do not actually require structure, only notation. Let's see how it is done in the previous cases. The capital D with square brackets. Superscript y with a dot on it. Now this may be interesting. You type y, and then you go and insert an attribute, which is the overscript. So any number, letter, value, in this case dot, is placed above the letter. We can see this by pressing F4. The second part is the one that needs an open close. In the derivative entry, within analysis, we find three possibilities. The derivative with respect to x, the x is already entered by default. A generic derivative of order n. The partial derivative. All three provide a closure, while the generic derivative of order n also provides a separator at the end of the index of the order of the derivative. If, then, I have to write dy over dx, I need only select this. Here it is. The structure with the open close already appears. This is because I had already selected full insertion in the preferences. Otherwise I can say no and just insert it with a Ctrl K. Okay, we have the derivative of y with respect to x. Should the index also be entered, a separator will be inserted after the number indicating the degree of the derivative. In the case of partial derivatives, similarly, the specific derivative will be entered. So we have the derivative with respect to x, and the generic derivative, and the partial derivative.